Alright, let's go ahead and get started on our second episode of our sed implementation in Haskell. And this episode we'll have to kind of think of how we're going to handle the internals of our implementation. That's often the most complicated part of creating a program, so there may be some complicated concepts involved here, especially since we're going to try and make this a completely functional, purely functional implementation of sed that only interacts with the outside world, or in other words, only uses the IO monad in the main function. So at the end, I would like to have a sed implementation that I can call as a function with a list of commands, and then we're just going to use TIO interact to tie that to the command line. So to do that, we're going to have some concept of state in sed, because we need to know as we're processing through the text what line number we're at, for instance, what the current hold space is, what the current pattern space is. We kind of need to collect an output as we go along. So all of those things point towards us needing some kind of data type that will hold that information. And so to do that, I'm going to make a new data type called sed state. And inside sed state, I'm just going to put the types I just mentioned. Like I'll have the line number, which will be an int. I'll have the input text, which will be a t.text. The pattern space, which will be a t.text. And these are basically just all the windows that we had split up in our sed tutorial videos. Except now we're representing them as the actual memory instead of in a visual manner. So now that we have that, let me make it a little bit prettier with the tabularize plugin. And we're going to need to use this state object inside of a state monad. And to do that, we'll have to import the control.monad.state library. We also know that sed is going to take a list of commands. So I want to be able to type in here, for example, print, next, delete, etc. And eventually we'll parse that out of a string using the actual sed syntax, but for now this will be sufficient. And now TIO interact will need to operate on this whole thing instead of just you'll have to wrap it in parentheses. Or another way you can do it is by putting a $sign to allow. This implicitly states that everything after the $sign is wrapped in parentheses. Right now we're having a problem with these data constructors because we haven't actually created them yet. So let's make another data type just called command. And a command can be either print, or it can be delete, or it can be next, or it can be substitute with a string and a string and a list of chars for the flags. But we don't need to implement every command right now. We'll just make a few and try and get a very simple implementation up and running. So now it's complaining that we're feeding sed a list of chars or a list of commands, and it doesn't know how to do that. So we'll change the type here, and we'll give it a list of commands. So we will need to have a command, some kind of function that will run all the commands on a single line. So this will take a list of commands, and it's going to return a state monad of the sed state data type, and the return value will be a t.text, because that's eventually what we want to get back from our program. So we'll have this, and we don't really know what we're going to do with it yet. So for right now, let's just write this with a get return, and because we need it to return a t.text instead of a sed state, we can use the output method or function that we have right here. So we'll just say return and compose that with output. And we don't need this label right now, so we'll just kind of erase that to get rid of the warning. And then, or actually we're going to need it in a second, might as well leave it. And then we need to evaluate the state of this function. However, now we're getting an error. We are using t here when we need a sed state. So eval state needs some default state object to run on. So we'll make a default state, and we'll just define that here. Default state is a sed state. The initial line is going to be 1. The input is going to be just going to be t. The pattern space is going to start off as the first line of t, and the hold space and output are just going to start off empty. Okay, so now we need to run these commands in our run commands function. So we'll need a way to run each specific command, and I'd like a function for each command, such as run command print, run command delete, run command next, etc. So let me just comment those out for now. And run command, we'll make a type signature for it. It's going to take, not a list of commands, a single command, and it's going to return a state, sed state, nothing, because it's just going to do an action. It doesn't actually return anything. So we'll do run command print, and it's going to get the current state, and then it is going to take that state, and it's going to change the output. It's going to print whatever's in the pattern space to the output. So it's going to get the output of SS, and it's going to append it to the pattern space of SS, and that will be the new output. Okay. And then we may have done something wrong here. Match expected type. Identity with actual type. Sed state. Because we need to return something, so we'll need to put a return right here. Oh, I see, but we're returning something that we don't want to. So we can do something like that. Yeah, something like that. However, I think we can, we don't need all these returns or this get. There's actually a simpler way. We can just use the modify function and then feed it a function that converts a sed state to another sed state. Great. So now in run commands, let's make a do block, and at the end we're going to just return the output of the final state. We don't know yet how we're going to do all this, but we know that we're going to run all of these commands. So we'll just, and they don't have any output, so we can use an underscore on our mapim. So we'll mapim run command over all the commands, just like that. Okay, so let's try this out with just print in our command list right now, and just see if we have anything running yet. And we get test. Okay, so we're just getting the first line, because what print does is it appends the pattern space to the output, and the original pattern space is just the first line, but we never repopulated the pattern space with the next line, so we never moved on to the next line. All we did was print it and then we're done. So we need some way to move on to the next line. So let's go ahead and make our next command, and then we can use our next command to move to the next line. So we'll kind of orient this much like our print command, except now we need to change the line number. So line number is now going to be the line number plus 1. We also need to change the pattern space. The new pattern space is going to be the input broken up into lines like this at the index of the current line number, because indices we know start from 0 and our line numbers start from 1. So just like that. And then we should be able to do something like we can do something like run command next here, and that will run to the next line, but then we need to run all the commands again each time we do run command next. So we could, find out how many lines the input is and just do this that many times, or we can make this run commands function a recursive function and just call it over and over again and finish once we reach the end of the input. So one way we could do that is we could make an if statement and say if the current line number is equal to the length of the input, which is, let's do it like this. If it is equal to the length, then we know we're at the end. And we need this above because we're using SS in this line. Then we're going to return the output. Otherwise, we are going to run the next command, and we're going to run all of the commands again. So all of the commands on that next line. And we don't need this. Okay, and let's try that. Great, so that worked, except we're not getting new lines after each line. We're just getting test this out instead of new lines, and I suspect that has to do with this t append right here, which is just appending the text together without a new line. Not really sure of a better way to do this, so we might have to manually change these into lists and then use t unlines to put new lines in between all of them. So one way we could do that is, because of the length of this line, I'm just going to delete all this and make a variable, for lack of a better word, called new output, and new output is just going to be equal to the t.lines of output ss concatenated with the t lines of pattern space ss. And then we need to run t unlines on new output. And we're getting that ss is not in scope because we are using this function here. So one way we can do this is just use a hanging indent like this, and then we can use a let instead of a where, and then use an in here. So let new output equal this in this, and then we're running t unlines. Great. And now we get our new lines just like we wanted. Perfect. So now we have a very, very basic implementation of the print and next commands. It'd be very easy to make our delete command. In fact, let's just go ahead and do that. It's so easy. All we're going to do is empty the pattern space with our delete command. So there it is. And now we have three basic commands in our program, in our implementation. However, it's a little bit messy. These lines are a little bit long, and I'd like to clean them up a little bit. And we need to go ahead and implement the rest of these commands and see if the way that we are processing this is efficient or not. So we'll kind of leave some of those tasks for next time. I am kind of pleased with this for an episode. We have a basic implementation that will parse through some commands and operate them. And it shouldn't be too difficult to add more commands in this format. So let's go ahead and cut this episode off there, and I will see you next time. We can go ahead and oops, looks like I accidentally compiled at some point, so we'll delete these, and then we'll take a get status and we can diff it. So you can see I changed the link in the readme, and this is what we changed in this episode. We added all of that, and that looks good. So I'm going to go ahead and add all of that, and I'm going to commit it as basic command implementation, except we don't need it really capitalized. Basic implemented a few basic commands, something like that. And we'll commit that, and we will tag it as episode 2. Oh, what happened there? Tag episode 2 is B860719. I guess I accidentally had made episode 2 earlier. Alright, back to the man page. How do we delete one? So we can git tag delete episode 2, and then we can tag this as episode 2, and we're good to go. So I will push this up to the GitHub repository, and I will see you at the next episode. Thank you so much for watching.